Okay, welcome. This is the week 3 lecture for outcomes 1 and 2. And what we're going to be covering this time is why do we graph? What's the purpose of this? Why do we spend the time to do that after we collect data? What types of graphs do we use in biology? The characteristics of the graph, or what am I looking for when I'm grading your graphs? Which graphs should you use? So if you have a data set, you need to choose the best graph to represent that data, and we'll go over how to do that. And then I'll offer you some practice. I'll give you some data sets, and then you can see how you think you would graph it, and I'll tell you the answers. Okay, so why do we graph? We graph because tabular data is really hard to interpret. If you look at the upper right-hand corner here, you probably have very little idea what's going on in this data table. But when you graph it, like underneath here, you can see trends. You can do projections on what's going to happen in the future, maybe. All kinds of good things you can do with graphs. Okay, and so how this all came about is really in 1886, this guy William Playfield, who was a Scottish economist, he wrote a paper called the Commercial and Political Atlas. And what he was able to do with some graphs is show how the trade imbalance altered the economic landscape in Britain's favor at the time. And so if you look at the graph down here, you can see where Britain really kind of surpassed Denmark and Norway as kind of the economic leader of Europe at the time, which had huge consequences politically and economically. So after this, really economic and science journals started using graphs much more often, and that's a trend that's continued today. So here's a modern day example of this, and this is a very famous graph by a famous scientist called Charles Keeling, who's an atmospheric scientist. And what Dr. Keeling was able to do is he collected information about the amount of carbon dioxide in the air each month. And what he found is the amount of carbon dioxide in the atmosphere oscillates summer to winter. So when it's summer in the northern hemisphere, the plants are soaking up more carbon dioxide. So atmospheric carbon dioxide goes down. And during the winter, when the plants are dormant, that atmospheric carbon dioxide increases. So there's this oscillation. And then what he was also able to show was there's an increasing trend in the amount of carbon dioxide in the atmosphere. And this has been used as a mechanism for global warming. So a very interesting graph, and you can see what the data looks like in the upper right-hand corner there. It'd be very hard to discern what's actually going on. But if you look at the graph underneath, it's much more clear. And this is why I use graphs. It's just to help us understand our data. So the characteristics of graphs, or what am I looking for when I'm grading your graphs? The first thing I'm going to look for is a title that completely describes the graph. So you could say, you can make it a sentence, the effect of hours of studying on test scores, or more simply, just say your dependent variable versus your independent variable, or test scores versus hours of studying. Okay, next I'm going to look to see that you have your graph set up correctly. Now the independent variable, this is the one that I changed during the experiment, that will always be graphed on the x-axis, or the bottom line. And then the dependent variable, or the thing that you're measuring, will go on the y. Okay, so the thing in this graph we're changing is the hours of study, and the thing we're measuring is the test score that resulted from that studying. Each axis needs to be labeled, and that label needs to include the units if it's a measurement. Okay, so hours, percent, milliliters, grams, something along those lines. So if you're measuring it, it should tell me what you measured in. And the last thing is the scale. Okay, the scale needs to be continuous. And what that means is it should be numbered consistently throughout your graph. So if we look at this one, on the x-axis, we have, it goes 5, 10, 15, 20, 25, 30, and 35. So by fives. That's completely appropriate. It would be inappropriate to go 5, 10, 20, 30, 40, and switch it up in the middle of your graph. Okay, setting the scale is often the hardest thing, because you have to look at the range of your data, count your lines, and then figure out how best to scale it. And that can be difficult for students when they first start. Okay, so the types of graphs. Really, in biology, we use 4 types of graphs. The bar graph, the pie chart or pie graph, the line graph, and the scatter plot. And you need to know how to make each one of these, but more importantly, you need to understand what types of data would be used in these graphs and choose the graph that best fits your data. Okay, so a bar graph. A bar graph is used to track a variable over multiple groups. Okay, so when you have a grouping of different things. Bar graphs are graphically sometimes easier to read than their cousins, the line graphs. And like a line graph, the bar graph can be used to track a variable over time, but only if that time variable is a large increment, like months or years. You wouldn't want to use a bar graph for seconds or minutes. You'd want to use, again, its cousin, the line graph. So the examples we have here, we have the 2007 SAT math scores, and they have it by group. So, 100 point groups, and then the percentage of students that scored in each group. The second graph in the upper right hand corner, we have the amount of sugar in certain foods. So we have the food categories at the bottom, and then the percentage for sugar in each of those categories. That's probably an average, I would imagine. In the lower left-hand corner, we have the students' favorite after-school activities. And this one's, the axis is rotated, which you can do in bar graphs, but you can't do in other types of graphs. And so on the y-axis, we have the categories of different activities, and then the number of students that identified with that activity. And then lastly, we have the high temperatures of 2009, so a change over time. Okay, but the variable here is in months, which is a large increment, so that would be appropriate for a line graph. Okay, so a bar graph. Pie chart. A pie chart is used when you want to show a percentage, or when you want to show a part as a whole. And so the best way to see this is we'll just look at these examples. Okay, so the first graph in the upper left-hand corner is population of countries of the European Union in 2007. Okay, and then the categories are all the different countries, and you can see what percentage they made up of the European Union in 2007. Okay, so that's 100% of the population was, and then what percentage each country. Student grades is the next one in the upper right-hand corner. And so this is probably for a single test or something like that, and it tracked how many students scored in each category or each grade group. And then you can see the percentage there. In the lower left-hand corner, we have the hours of the day and then different activities that this person spent doing those. So presumably this would be a part of a whole. A day is 24 hours, so if you add those up, they should add up to 24 hours. And it shows how much time are they spending doing this in a day. And the last graph is the weather over a 2-week period. Okay, so how many days in each category. Okay, so again, a percentage or a part of a whole, so you can see how you relate to the rest of the group. The line graph. The line graph is one of the graphs we use most often in biology, and it's used to graph change over time. So anytime you are taking a measurement at different time periods, you could use a line graph. Now these are some of the easier graphs to set up because the time interval is always going to go on the x-axis, and your dependent variable, or the thing you're measuring, will always go on the y. Okay, so the examples I have here, the first one is the number of dolphins seen in the Santa Barbara Channel over a 6-year period. Okay, and we can see that each year they spotted a certain number of dolphins, and it's tracked on this chart. Okay, a line graph, you connect the dots. You should have one dot for each time period. The second graph in the lower left-hand corner is the Red River discharge rate, or how much water was in the river channel at given times. Okay, and we can see here that there was an increase in the amount of water in April and August, so this must have preceded some wet period. And then we have the value of Sarah's car. Okay, and so we know the cars depreciate in value over time, and so that's captured here. Now, graphs can be positive, negative, or cyclical. The first graph you can see is generally positive. We start with a fairly low result, and then the dots generally increase over time with a little bit of variation, but still looking like it's increasing. The second graph, we can say this is cyclical. It's kind of go up and down, up and down. And if you were to compare years, you'd probably find that 1994 looks similar to 1993. Maybe the amount of water was different, but the cycle was probably something you see every year. And then the last one, that's a negative value because the line is decreasing over time. So the card is getting less value over time. Okay, so line graphs charts change over time, and it can be positive, negative, or cyclical. The scatter plot graph. Again, we use this very often, especially if we're going to be graphing like the class data. We'll use a scatter plot. And we do this when we have two related variables. Okay, the independent variable, or the thing that I'm changing, again, goes on the x-axis. And the dependent variable, or the thing you're measuring, goes on the y-axis. Just the same as a line graph. Okay, and so you can see in the example here we have GPA, so we're looking at the change in GPA, and then the percentage of attendance for those students. And you can see that for any GPA like 3.0, there's many students that have a 3.0, and then you can see their attendance rates are all above 80%. Now, one thing about a scatter plot is you don't connect the dots. It wouldn't make any sense to connect these dots here. And so what you use is what's called a line of best fit. You can see that in the bottom graph. Okay, a line of best fit is where generally half of the dots are above the line and half of the dots are below. If you make your data in Excel or numbers, there's a program that will do this for you. If you're doing it by hand, you just got to kind of count your dots and generally, you know, draw a line where that's true. Half the dots are above and half the dots are below. If you're off by one or two or just a few, I wouldn't count it against you when you do it by hand. Okay, so let's practice. We know how we should use each graph, and so let's look at some topical data and see if you can pick out which graph you should use to graph it. Okay, so go ahead and pause the video, look at the tables, and decide how you would graph it. And in the next slide, I have the answers. So go ahead and pause now. Okay, and so here's how I would graph it, or how you should graph it. Okay, table 1, what we're doing here is looking at change over time, or is tree height associated with the age? So the older the tree, is it taller? We can do that in a line graph. Table 2, this one's an interesting one because we could graph it two ways, as a line graph, a bar graph or a pie chart. Okay, so we have different categories, red, blue, green, and yellow, which you could set up as a bar chart. And then the number of students who would be on the y-axis. Or you could do this as part of a whole. Okay, so if you wanted to show how with the whole group and how they scored. Table 3, this would be a scatter plot because you have two related variables, depth and the number of fish. So depth, that would be your independent variable, the thing you're changing. You're going down in depth, and then you're counting or measuring the number of fish at each depth. And the number of fish would be on the y. And the last table, we have years of education as a percentage of the population. And so because it's a percent of population, you want to show that as a pie chart or pie graph. So I hope this helped you kind of understand why we graph, the 4 different types of graphs you're going to be using in this class, how you're going to be graded when you make a graph, and then how to choose the best graph for your data. If you have any questions, just come find me in class, and I'd be happy to discuss this with you further. Okay, have a nice day, guys.